The learning objectives for this section on anchor uplift are to 1, understand the difference between conservative approximations and reality, and 2, apply more robust calculations when appropriate for what is the anchor uplift reality. Now, in order to understand the difference between approximations and reality, we will start with a refresher on what we do to calculate uplift in BP211, the suspended bridge design course, and the Bridge Builder manual. Do you remember what our main force resisting uplift is? Right, overburden. Now, figure 4.9, equations 4.36 and 4.37 in the manual show how to calculate overburden, and this is echoed and taught in BP201. However, there are two major assumptions being made here that we can eliminate. First, the entire overburden area, except the anchor, is assumed to have the density of fill. The first thing we can do is split our overburden into components and apply their specific densities. This will increase our capacity because the fill has the least density of any material in the mix. And if you're doing this via AutoCAD, I like to do this last or towards the end of sharpening the pencil and finalizing the design, because it can take a little while to make sure you have all of the areas right. Or you can have your design tool update this automatically. So here we would have area or the density of concrete, density of fill, and the density of masonry. Second, the manual and BridgeDU only teach to account for the ramp above the anchor in a trapezoidal shape parallel with the bottom of the anchor. Some standard abutments will require you to consider the additional ramp area above the horizontal in order to resist uplift. So what we're previously considering is this flat area here. And additionally, we want to consider if the approach ramp has a slope, there will be an additional overburden that is caught within that 30-degree angle off the vertical. This is only the case with, like I said, abutments with approach slope, of course, but it can add significant capacity. The simplest way to build this into your design tool is to have a toggle to use additional ramp area, on or off. The area can be measured in AutoCAD or calculated based on the approach ramp angle, alpha, shown in the image here. This value can then be added to your overburden.